we're solving problem 7 from the 2024 AIME1. Find the largest possible real part of this equation up here, where z is a complex number with absolute value of z equals 4. Here I is the square root of -1. The first thing we can do here is we can simplify it a little. So we know that z is a complex number, so we can just stop there. The standard form of a complex number is a plus bi, so we can just let z equal a plus bi. Then this equation becomes 75 plus 117i times a plus bi plus 96 plus 144i over a plus bi. We can do something, we can manipulate this side to get us, and we can call this very complex number w, just to make things simpler. W is equal to 75, that's a weird 7, 75 a minus 117b plus I times 117 a plus 75b, and then for this side we can factor out the 48 on the top, so 48 times 2 plus 3i over a plus bi. Now the next steps we do is all of this doesn't really matter. It's just simplifying, but we have to find a really unique way of simplifying that gets rid of this denominator. So basically, if absolute value of z equals 4, z squared is going to be equal to 16. So what we can do is we can apply difference of squares here. If we multiply by an a minus bi, it would cancel out, leaving an a squared plus b squared, which is equal to z squared, or 16. So I don't want to write all of this out again because it's the same, but right here, if we do 48 in the parentheses 2 plus 3i, a minus bi, and then divided by a plus bi times a minus bi. All of this simplifies, but I'm going to write it a little bit smaller now. 48 times 2a minus 3b, that's plus 3b. And then on the top we can factor out the I, and this becomes 3a minus 2b, and then divide this by a squared plus b squared, which we know is 16. So then, since 48 can divide into 16, we have this equation, and then we can simplify it out with all of this, with this up here, since it's still here, it's just dots, put it as dots, I don't want to write it out again, but you can just simplify it down by subtracting and adding like terms, so you get that w is eventually equal to 81a minus 108b. Now here, what we can do is we can use sine and cosine for this. So we let a be equal to 4 cosine of theta and b equal to 4 sine of theta. Then the equation becomes 324 cosine theta minus 432 sine theta. And then we can use the Cauchy-Schwarz inequality. I don't know if I'm pronouncing it right, but use the inequality, and it's 324 squared plus 432 squared times cosine theta squared plus sine squared theta. This has to be greater than or equal to all of this squared. So 324 cosine theta minus, I'm just going to write it down here, 324 cosine theta minus 432 sine theta squared. Now here, I know this looks weird, but I don't have really space to write this, so this is greater than or equal to this. So we can get rid of the square. We get 540 squared times 1 greater than or equal to 324 cosine theta minus 432 sine theta. And right here we have our answer. Because we want to maximize the value, our answer is simply going to be 540 for this problem, and we are done.